Welcome to Neural Network Fundamentals. I'm going to take you on a journey from complete beginner to understanding deep learning. And here's the best part. We are going to start with something incredibly simple. Everyone talks about neural network like they are this mysterious complex technology that only PhD researchers can understand. But I'm going to show you that at its core, a neural network is built from something you can grasp in just a few minutes. We are starting with the absolute basics. What is a neural network? And to understand that, we need to understand just one neuron, not a network, not layers, just one single neuron. Because once you understand this building block, everything else makes sense. This is a single neuron. It might not look like much, but this simple diagram represents the foundation of every neural network ever created, from the ones recognizing your face in photos to the ones powering ChatGPT. Let me walk you through what we are seeing. On the left, we have inputs. Think of this as piece of information we want to analyze. In the middle, we have our neuron. The circle represents our processing unit. It's like a tiny decision maker. On the right, we have our output, our answers or predictions. Now, what does this neuron actually do? The operation is beautifully simple. It takes each input. It multiplies each input by a number called a weight. It adds all these products together. It adds one number called a bias. The sum becomes our output. That's it. That's the entire operation of a neuron. Let me make this concrete with an example everyone can understand. Predicting house prices. Imagine you are trying to estimate how much a house is worth. What information would you look at? The size of the house? Bigger houses typically cost more. The number of bedrooms? More bedrooms usually mean higher prices. Now, how far it is from the city center? Location matters for price. So, our three inputs are size, input, and distance to city. Now our neuron needs to learn how important each of these factors is. From looking at lots of house sales data, it might learn each square foot adds about $150 to the price. Each bedroom adds about $10,000 to the price. Each mile from downtown subtracts about 2000 from the price. Plus there's a baseline price of 50,000. These numbers $150, $10,000, $2,000 and $50,000 are what we call the weights and biases. So for a specific house, let's say 2000 square feet, 3 bedroom, 5 miles from downtown, our price will be 2000 multiplies by $150 plus 3 multiplies by $10,000 plus 5 multiplies by minus $2,000 plus $50,000 for baseline. Let me calculate this step by step. $2,000 multiplies by 150 equals to $300,000. That's for the size. Then again, 3 multiplies by $10,000 equals to $30,000. That's for the 3 bedroom. Then again, 5 multiplies by minus 2000 equals to minus $10,000. That's for the distance. Total 300,000 plus 30,000 minus 10,000 plus 50,000 equals to 370,000. So our neuron predicts this house is worth $370,000. Now here's something that might surprise you. What I just showed you, the single neuron is actually doing linear regression. If you have ever seen linear regression before, you know it looks like y equals to m1x1 plus m2x2 plus m3x3 plus b. Our neuron is doing output equals to w1 multiplies by input 1 plus w2 multiplies by input 2 plus w3 multiplies by input 3 plus bias. They are exactly same, just with different names. M coefficient, that equals to weights, y output, that equals to the neuron output, and b intercept, that equals to bias. So why don't we just call it linear regression? Why this fancy neural network terminology? Because this single neuron is just the beginning. The magic happens when you stack hundreds of thousands of these neurons together, connect them in layers, add special functions that create non-linear behavior. But it all starts here with this simple linear combination that you now understand. You will often see this written in a more compact mathematical form. The equation output equals to W transpose X plus B. Don't let this intimidate you. This is exactly the same calculation we just did. W represents our weights, X represents our inputs, B represents our bias, that little t means transpose. We will learn more about that soon in our upcoming videos. So when we had weights equals to 150, 10,000 and minus 2,000, input to 2003 and 5 and bias 50,000. This compact gives us the same $370,000 result. Why write it this way? Because it's much cleaner and easier to read. Computers can calculate this form very efficiently. It scales beautifully for 3 inputs to 3 million inputs. It's the foundation for building deeper networks. So let's recap what we have learned. A single neuron is essentially linear regression with fancy names. It takes inputs, multiplies by weights, adds them up with bias, and gives you a prediction. This might seem simple, but you have just understood the core building block of every neural network. Every breakthrough in AI, from image recognition to learning models, is built on this foundation. In our next video, we are going to learn about functions, the mathematical concept that will help you understand how neurons process information. We will explore what functions are, why they matter, and how they lead us naturally to the idea of neural networks. But for now, remember, you have just learned the secret of neural networks. It's not magic, it's just smart mathematics, starting with this simple linear combination. Thanks for watching this video, and I will see you in the next video where we will build the mathematical foundation to take our neurons to the next level. Bye.